the city of Townsville.
Oh, thank you, Sarah Bellum. I don't know what I will do without you. You're my favorite person ever. Why does my heart race every time Sarah Bellum is around? This calls for an emergency. Time to call the Powerpuff Girls.
Looks like the mayor's calling. Let's see what's the trouble now.
Hello, Mayor. What's the problem?
Girls, I have a serious issue. My heart is beating super fast. Please help. I don't know why is this happening.
I don't know if we can help with that, Mayor, but I think our professor can. He'll explain everything to you.
Excellent. I'll send Sarah Bellum there in an hour. I'll be busy then. Explain everything to her.
Listen to the sound of the heartbeat. Did you know that the scientific sound of the heart is lub-dub? The lub is the sound of the tricuspid and mitral valves closing. The dub is the sound of the aortic and pulmonary valves closing.
Wow, but how does the blood flow work, Professor?
You mean how my heart beats for... never mind. Proceed to the next slide for the diagram.
Superior vena cava is a large vein that carries the oxygenated blood from the upper body into the heart. Vital role in blood circulation. Returns oxygen-poor blood from the upper body to the heart for reoxygenation and recirculation. Located at the end of where the left and right brachiocephalic veins meet, emptying into the right atrium and is to the right of the aorta and trachea. Inferior vena cava, a large vein that carries the oxygenated blood from the lower body into the heart. Carries the oxygenated blood from the lower half of the body into the right atrium of the heart for recirculation and oxygenation. The inferior vena cava is posterior or behind the abdominal cavity and empties into the right atrium. Right atrium, the upper right chamber of the heart, receives the deoxygenated blood from the body via the vena cava and pumps it into the right ventricle, in between the right ventricle and the pulmonary valve. Tricuspid valve, valve that separates the right atrium from the right ventricle. Controls the flow of blood from the right atrium to the right ventricle and prevents blood from flowing back to the atrium. Located between the right atrium and the right ventricle. Right ventricle, lower right chamber of the heart that receives the oxygenated blood from the right atrium. Receives the oxygenated blood from the right atrium and pumps it into the lungs via the pulmonary artery for reoxygenation. Located in the lower right portion of the heart and is opposite to the left ventricle. Pulmonary artery delivers the oxygenated blood to the lungs, pumps blood away from the heart to the lungs. The pulmonary artery transports blood whose oxygen content is relatively low. Blood with little oxygen content is delivered to the lungs via the pulmonary artery. At the base of the heart's right ventricle. Divides into the left pulmonary artery and the right pulmonary artery. Left atrium. Acts as a holding chamber for blood returning from the lungs and to act as a pump to transport blood to other areas of the heart. The left atrium receives oxygenated blood from the lungs and pumps it down into the left ventricle, which delivers it to the body. The left atrium is one of the 4 chambers of the heart, located on the left posterior side. Left ventricle, the thickest chamber of the heart and the most hard-working chamber. Responsible for pumping all oxygenated blood throughout the body. Located in the bottom left portion of the heart below the left atrium. Pulmonary vein. The vein that carries oxygenated blood from the lungs to the heart. The pulmonary vein is responsible for carrying oxygenated blood from the lungs back to the left atrium of the heart. The pulmonary vein is found connected to the left atrium. Bicuspid valve, also called the mitral valve, prevent blood from flowing backward as it moves through the heart, between the left atrium and left ventricle, located on the left side of the heart. It has only 2 leaflets. Aorta, the central conduit from the heart to the body, supplies oxygenated blood that branches off to go to the head and neck, the arms, the legs, and the major organs in the chest and abdomen. The largest artery in the body, the aorta arises from the left ventricle of the heart.
Now, let us ponder on how the blood from the heart reaches the different parts of the body. The answer is simple. The heart is able to deliver blood to different parts of the body through the blood vessels. Our body consists of a network of blood vessels. They can be classified into 2, the arteries and the veins. I'm sure Mr. Mayor can be a good model for the blood vessels. Back to the lab, shall we? What we have here is a blood vessel. A beauty, isn't she? As I've mentioned before, we have 2 types of blood vessels. Conducting vessels called arteries function to transport blood away from the heart. Don't be fooled by their fragile appearance. Artery walls are very thick and strong. As the heart beats, they also expand and recoil. The largest vessel, the aorta, is also an artery. On the other hand, vessels that transport blood back to the heart are called veins. And finally, the blood vessels submit into capillaries, which provide tissues and target organs with nutrients and oxygen.
The blood is the only fluid tissue in the body. It's classified as a connective tissue. It is 5 times heavier than water. Oxygen-rich blood has a scarlet red color, while oxygen-poor blood has a dull red or purple coloration. It is made up of solid and liquid components. Also called erythrocytes. Main function is to carry and deliver oxygen to the different cells in the body. Biconcave, enucleated cells with very few organelles. RBCs have iron-containing protein called hemoglobin. Platelets are not technically cells, but are fragments of ruptured multinucleated cells. They are irregular in shape. Their function is to stop blood loss from broken blood vessels. Also called leukocytes, they are crucial in the body's defense against disease. Unlike erythrocytes, WBCs are complete cells with a nucleus and its organelles. White blood cells are usually larger compared to RBCs. However, they are smaller in number. Coronary artery disease develops when the major blood vessels that supply your heart with blood, oxygen, and nutrients become damaged or diseased. Cholesterol-containing deposits, plaque, in your arteries, and inflammation are usually to blame for coronary artery disease. Congenital heart disease, congenital heart defect, is one or more abnormalities in your heart structure that you're born with. This most common of birth defects can alter the way blood flows through your heart. Defects range from simple, which might cause no problems, to complex, which can cause life-threatening complications. Peripheral artery disease, also called peripheral arterial disease, is a common circulatory problem in which narrowed arteries reduce blood flow to your limbs. Peripheral artery disease is also likely to be a sign of a more widespread accumulation of fatty deposits in your arteries, atherosclerosis. This condition may be reducing blood flow to your heart and brain, as well as your legs. Damage to heart muscle and heart valves from rheumatic fever caused by streptococcal bacteria. Rheumatic fever most often affects children who are between 5 and 15 years old, though it can develop in younger children and adults. Anemia is a condition in which you lack enough healthy red blood cells to carry adequate oxygen to your body's tissues. Having anemia can make you feel tired and weak. Hemophilia is a rare disorder in which your blood doesn't clot normally because it lacks sufficient blood clotting proteins. If you have hemophilia, you may bleed for a longer time after an injury than you would if your blood clotted normally. Leukemia is cancer of the body's blood-forming tissues, including the bone marrow and the lymphatic system. Leukemia usually involves the white blood cells. Your white blood cells are potent infection fighters. They normally grow and divide in an orderly way, as your body needs them. But in people with leukemia, the bone marrow produces abnormal white blood cells which don't function properly.
Wow, Professor, you really know a lot about this. It makes my heart skip a beat.
Is that so? Well, Miss Sarah, would you do me the honor to take you out for dinner?
Of course, I'll ask the mayor if I will be free later this evening. Good afternoon, Mayor. I'm here to tell you I already spoke to the professor and we're getting dinner soon.
Please ask the professor what's the anatomy of the broken heart during your date this evening.
So, once again, the day is saved thanks to the Powerpuff Girls.